Hi, everyone. Welcome to SUSECON 21. My name is Hayden Barnes. I'm the engineering manager for Windows on Rancher. We're here today in my home lab. You see my system set up, more computers over here, and of course my classic, it's a Linux system, I know this shirt from Jurassic Park. I'm in charge of Windows on Rancher. I'm also very familiar with WSL, and I'm here to show you how to set up Rancher on K3S on WSL. If you've never used the Rancher interface, this might be a great way to check it out, experiment with it before you move it into production. And it just gives you a good introduction to what WSL is, what its capabilities are, and if you're not familiar, and maybe you'll learn some about WSL or K3S, Helm, or Rancher. Let's get started. We're going to cover what is WSL, Windows Subsystems for Linux, the use case for WSL, how to get started, and a demo of installing Rancher on WSL. So what is WSL? WSL is a novel, lightweight Linux environment for Windows. WSL 2, the current version, is powered by a slim Hyper-V environment, a VM layer native to Windows that boots a Linux kernel to a shell in under 2 seconds on most devices. This provides a space for using Linux tools to build, debug, and test applications and administer network systems, cloud, whatever you traditionally used Linux for. WSL also offers integrations with Code, Visual Studio, JetBrains IDEs, and other tools. Another advantage of WSL is choice. WSL allows the user to choose from multiple Linux distributions to use. You can download them from the Microsoft Store or sideload them from other sources like OBS or GitHub, or even create your own Docker image and export it and import it as a distro. You can even create your own custom kernel. Microsoft provides a kernel for WSL2, but if there are features in a kernel you need, now this is in a VM, so adding hardware drivers doesn't make that big of a difference. But if you want, for example, enhanced KVM performance, that's something you can build into your custom kernel and boot. So there's a high degree of customization with WSL. I often say WSL can be what you make of it. It's a toolkit on which you can build your workflow. So here's an example of launching OpenSUSE Tumbleweed on WSL with the Windows terminal. It's that fast. And then we're going to update our image with Zypper. And it looks like a regular console on the server. So why would you choose WSL over bare metal Linux, VMs, or the cloud? That's a question I get regularly. First, you just saw the speed. There's no waiting for a full-fledged VM to boot. In Hyper-V or VirtualBox or VMware, you're just there at a shell. You're also not waiting for a cloud instance to be provisioned. You also get immediate access to your local file system and code. There's no SCP or GitHub, branches that you then need to push and then pull back on your cloud box. It's just there. WSL offers extensive integration with Windows, including automatic mounting of your Windows drives, shared environmental variables, running Windows applications from WSL and vice versa. One of my favorite use cases is when I build applications is to build them for Linux in WSL. And then when I'm done and it's an appropriate cross-platform application, I change my compiler flags to build for Windows and then build a Windows binary and then copy that to Windows. I can test it right there, building for Linux and Windows side by side. You can even pipe terminal output between Windows console and Linux terminal applications. You can even include PowerShell in there too. So you do a git commit, you export, you can pipe that to PowerShell and use OLE in Windows to attach that to email in Outlook, and you're ready to commit that to a listserv to share that change with the rest of LKML. So you can really customize having the capability of both Linux and Windows together. Another reason for WSL is that many enterprise environments mandate Windows devices for compliance purposes. They require this for developers and administrators too, and for a long time that's hampered developers and administrators. Some of them have their own VMs that their compliance department may or may not know of. They may use their own devices. They may tolerate unmonitored Linux machines. But when you're dealing with mission critical systems, it's really important to be compliant. And WSL can provide that Linux tooling in the compliant environment on Windows, that makes enterprise decision makers happy. So it's an option when pure desktop Linux is not. So here's an example of the integrations between Windows and Linux. WSL View is a utility that's part of WSL Utilities. It's packaged by the community. It's available for OpenSUSE. There's a zipper repo. And running WSL View on that file, that PNG, opens it in Windows Photos. So you can do that with websites, and it'll open with your default Windows browser. So there's a lot of integration there that makes WSL super powerful. So how do you get started with WSL? You need Windows 10. You need to enable WSL. You need to enable Virtual Machine Platform to get WSL 2. You need to install a distribution from the Microsoft Store or sideload it from a third party like SUSE. And then I highly recommend you install Windows Terminal. Windows Terminal is the replacement for the legacy console on Windows that dates back to NT4. And the new Windows Terminal is faster, it's GPU accelerated, it is highly customizable. You'll see an example of how I've customized mine for Tumbleweed, and it is just a much better experience. You'll have a much fuller experience using WSL with Windows Terminal. So I highly recommend you install that alongside WSL. So for WSL2, you need Windows 1903, also known as build 18392 or higher. If you're on the general release cadence right now, you should be on a build around 19041 or 19042. There are also, of course, the Insiders builds, the Bleeding Edge Insiders Dev, the slightly more stable Insiders Beta, and then the release preview, which is the preview right before it gets shipped out to the general public. If you want the latest and greatest WSL features, they're going to be out there in dev. But there's a certain risk in being on dev builds, particularly on your main production devices, with bugs that could interrupt your workflow. So personally, my main machine runs beta, but my backup machine runs dev, so I can try the latest features there. But your risk tolerance is up to you. You can also run either one of these in a VM. So just think about your risk tolerance and what you want to try and where you install things. So you enable these features. You can do it in the Windows Features GUI, just from the Start menu, searching Windows Features, checking Virtual Machine Platform and Windows Subsystem for Linux boxes. OK, restart. You can also use PowerShell commands. Those PowerShell commands are on the WSL page on the OpenSUSE wiki. And on those dev builds in the Insider program, you can use wsl.exe --install, which will install everything, including the two features, the latest WSL kernel, as well as WSL-G, the new layer for GUI apps on WSL. That's the official Microsoft layer. Now, if you're not on Insider's Dev, you can still use GUI apps on Linux, but you'll need a third-party X server like X410 or VCXCRV. In the meantime, you'll need to configure WSL for that. Those programs have documentation on how to do that. And we've been doing that for a while, but WSL-G is going to be a super great replacement and even includes audio support. which I'm very happy with. Then you need a distro. So you can grab Leap from the store. You can, if you have a SUSE Linux Enterprise license, you can also grab it there as well. But if you want Tumbleweed, which I prefer, you can grab the image from OBS, from download.opensuse.org. In the virtualization repo, there's a folder for WSL, and you can grab the latest daily build. Now, the trick here is that you have to install a certificate that's bundled in the image in Windows for OBS. If you're not sure how to do that, I've got a blog post on my blog, boxofcables.dev, that'll walk you through the process of installing the OBS cert so that you can install Tumbleweed. Finally, from the Microsoft Store or GitHub repo, you can install Windows Terminal and get that great experience. You can customize your background, your icon, you can open different panels. It's just a much better experience over that legacy console from so many years ago. So now we're going to jump into a demo of Rancher on WSL. Why are we doing this? 1, to show you some of the cool things you can do on WSL. 2, if you're new to cloud native development, K3S, Helm charts, to kind of get a feel for what that looks like. And 3, if you've never tried the Rancher management dashboard, you can experiment with it and try it right here on WSL without having to deploy nodes on Azure or AWS. It's one of the advantages of WSL is that local development experience. So let's jump in. First, I'm going to open up my OpenSUSE Tumbleweed. We're going to use WSL Fetch. WSL Fetch is a take on NeoFetch, which you may have heard of. It gives us some of that Linux information, like our uptime, our kernel, but you'll also see it has our Windows build, and it shows that we are running on WSL 2. One thing of note is that it says we are on the Microsoft standard WSL 2 kernel 5.4. 5.4 is the current release. 5.10 is in testing on Insider's dev channel. You, of course, can customize this. One thing I would note is that the WSL2 kernel that Microsoft publishes on GitHub has a handful of out-of-tree patches that are optimized for WSL2, like around memory compaction and performance. So if you want to tweak your own kernel, I highly recommend that you fork it from the Microsoft WSL2 GitHub and then apply your tweaks there. All right. So first thing we need is K3S. So let's go grab K3S from the repo. We can't use K3D. K3D expects WSL expects systemd, which does not exist on WSL2. If you do a quick PSA, you'll see it has a very basic init system. That's how it's able to launch so quickly. But we can just install K3S manually. We'll wget the static linked binary and then move it into place in user local bin, kind of where it expects to be. Okay. And then we'll make it user executable just for now. We're going to be jumping into root here in a minute just because it's easier to run there. And for now, we'll make it user executable, K3S, check that version. All right, and we've got K3S. Now, the other thing we are going to need is Helm. We're going to grab that from the Helm website. We're going to curl bash that. We're living on the edge here with WSL between Linux and Windows. And we aren't afraid of a little curl pipe to bash. Git Helm. All right, that's in place. Check the version. All right, so we've got K3S and we've got Helm. So now I want to do a couple things. One, I'm going to jump into root because that's where K3S server expects to be. So we're going to SU over there. I'm also going to open another panel to do that work in. So I'm going to drop down, hold down Alt, click Tumbleweed, and I now have another panel in my Windows terminal. Another great reason to use Windows Terminal. All right. And then before we move on, we're going to do K3S Check Config, just to make sure we've got everything in place that needs to be in place for K3S server. And we pass. We've got all our kernel modules and hooks needed. Binary sum is verified. We're good to go. So let's start our K3S server. All right. So that is going. And while that is going, we're going to do some housekeeping. First thing I'm going to do is I'm going to alias K3S kubectl to just kubectl to make that shorter when typing. Next, let's go ahead and see where our K3S server is with kubectl cluster info. All right, it's running. Now, I'm going to set some environmental variables like Kubernetes master and kubeconfig so that Helm will be able to find the control plane and the other settings in K3S. Just copy and paste those in. All right. Let's make sure our cluster's still good. Looks like our cluster's running over here. All right, now we're ready to start installing. Let's create the namespaces we need for Rancher and Cert Manager. So we're going to use Cert Manager. Cert Manager is pretty powerful. We can do Let's Encrypt. Because we're doing everything locally and we're just demoing, we're going to use a self-signed cert. Nothing too fancy, just for testing purposes. But let's create first the namespace for Rancher, cattle system, and then the namespace for Cert Manager. There we go, just kubectl create namespace, cert.manager. Then we are going to apply, we need the repo to add to Helm for Rancher. Let's add that. Helm repo add Rancher latest. Grab that. Same thing with Cert Manager. We're going to add that JetStack repo. That's added, and then we're going to update those. Helm. Okay. All right, those are started. So we're going to go ahead and then apply our Cert Manager CRDs first. All right, those are created. And then we are going to install Cert Manager in that Cert Manager namespace. And we are deployed successfully. We see some activity on the API on the right. It's good to see. Let's then check that by checking those pods, see where they're at. Great, they're up and running. We've got our webhook. We are good to go. Next is Rancher. So we are going to install the latest Rancher into the cattle system namespace. We're going to call it rancher.local for our host name. That'll be relevant later. All right, and Rancher is deployed. Now Rancher might take a little bit longer to set up than the other, but we're going to check the status of that. We'll give that a few minutes to configure. We'll check on it again in a moment. Now, we used an arbitrary domain name, rancher.local. That is going to be relevant. So what we need to do is we need to add rancher.local to our hosts file. This is something specific to WSL and will come up later. So we're going to just echo 127.0.1 and rancher.local to our WSL hosts file. Gotcha. And then we can cat that, make sure it's there. All right, great. Let's go back and check on our rancher nodes, see how those are going. Oh, good. Those are set up and running. Okay, the next thing we're going to need is we're going to need the IP address of our WSL2 container. It has a separate IP address from the host Windows. It is its own NATed DHCP network. So in order to connect to it, we're going to need that. So we're going to do that by parsing essentially the output of IP with some fancy grep. And we've got 172.18.61.165. That is the IP address for our WSL2 container. Next, we need to add that to our Windows hosts file. And we're going to do that from WSL with PowerShell by calling PowerShell.exe from WSL. And it is not cooperating. It's trying to parse it as an application. That's fine. We can do it in regular PowerShell. It wouldn't be a demo if something went perfect. Am I right? So we're going to open Notepad and we're going to append that IP address here to our container in Notepad to rancher.local. File, save, exit. Now we're going to use WSL view, HTTPS, rancher.local. And this is in WSL. And it says our connection is not private because we've got a self-signed cert. So we're just going to continue. We know it's our system. And we have Rancher running on WSL on K3S. So we're going to set a password. We're going to continue. Here for the server URL, for our purposes, we are going to use that IP address just for now, for consistency. And we now have working Rancher dashboard on WSL. So thank you so much for joining me for this presentation, for learning about WSL and this walkthrough. The commands for all of this are in a gist on my GitHub. My GitHub username is Sir Redbeard. I'm also at Unix Terminal on Twitter. You can find me there. And I hope you have fun and learned a little bit and enjoy hacking on WSL. Thank you.